We will begin Chapter 6 on exponential and logarithmic functions with Section 6.3 on exponential functions. So let's start with an exploration. We'll consider the functions f of x equals 2 to the x and g of x equals 3 to the x. And we're to graph these functions by filling in the tables and labeling our graphs. Okay, let's start here with our f of x. And we're given these values for x, and we're to raise 2 to these powers, and that's how we get our f of x. So 2 raised to the negative 2 power. Well, 2 to the negative 2 is the same as 1 over 2 to the positive 2, and 1 over 2 to the positive 2 would be 1/4. Okay, let's do that again, now with negative 1. 2 to the negative 1 is the same as 1 over 2 to the positive 1, or 1/2. I'm sure that light is good. Okay, 2 to the 0. What's 2 to the 0? Any non-zero number raised to the 0 is 1, right? And of course 2 to the first power is 2, and 2 to the second power is 4. Okay, let's see where we are here with these. There. Okay, so we have negative 2, 1/4. Just kind of estimate where 1/4 would be here. We have negative 1, 1/2, 0, 1, 1, 2, and 2, 4. So there is our f of x. F of x. Okay, now let's do the same for g of x, 3 to these powers. So 3 to the negative 3 is the same as 1 over 3 to the positive 3, and 3 to the positive 3 is 27. So 1 over 27. 3 to the negative 2 is 1 over 3 to the positive 2, so 1/9. 3 to the negative 1, 1 over 3 to the positive 3, so 1/3. 3 to the 0, of course, is 1. 3 to the 1 is 3, and 3 to the 2 is 9. Okay. Let's graph these. All right, we have negative 3 and 1/27. I'm not going to really be able to graph that very well. Negative 2, 1/9, and that would, of course, be below. Negative 2 is 1/4 for f of x. A ninth is even smaller than a fourth, so it's somewhere between the x-axis and that point. Negative 1 and 1/3, that also would be somewhere between the x-axis and our 1/2. Negative 1 1/3, 0, 1, so that's the same point, isn't it? 1, 3, and 2, 9. So we start out here below, kind of skimming between the x-axis and the graph of f of x. At the point 0, 1, they come together, and then our g of x comes inside of the f of x and starts going up exponentially faster, right? All right, let's talk about the domain and range of each of these. So would they be the same? Yeah, it looks like they're the same. So what's the domain of both of them? All real numbers, yes. And the range, how low do we go? Well, would we ever touch the x-axis? To touch it, what would have to happen? Y would have to be 0. F of x would have to be 0. 2 to what power would give us 0? Well, there is no such number, right? And 3 to what power would give us 0? We could never get 0. So we can't go all the way to 0, but we get awfully close and all the way to positive infinity. So can y equal 0? Why or why not? No. That's what we just said. No. Because no value, I want to spell that with an F, no value for x exists such that y equals 0. There's just no value we can plug in for x to get a y equals 0. Does this function have symmetry? Do you see a point that we could fold across and make two perfectly matched halves? No, it has no symmetry. What are the x and y intercepts? Okay, well, we said we never get a 0 for y, and that's an x-intercept. Y has to be 0 for an x-intercept. So there are no x-intercepts. How about the y-intercept? Well, they both had the same one, didn't they? The point x is 0, y is 1. Notice that both of these functions are increasing as x increases. Remember, we talked about that increasing and decreasing. With the parabola, we saw there were two parts. One part was increasing, one part was decreasing. But this, however, as x increases, both of these are, the y values are increasing. So both of these are increasing. So what does this mean? As x, I'm going to use a little notation here, arrow goes to positive infinity, y goes to positive infinity. That's the definition of increasing. As x gets bigger, y gets bigger. Which function is increasing faster, f of x or g of x? Yes, g of x. G of x is increasing faster. So the 2 and the 3 here represent what we will call, we'll talk about it in a minute, the growth factor. And so the growth factor for g of x is a bigger number, so it's increasing faster. Do these functions have a horizontal asymptote? Do they approach a horizontal line but never touch it and get closer and closer to it? And if so, what is its equation? Yes, the what? X-axis. What's the equation for the x-axis? It's a horizontal line, so it's y equals, and y equals what on the x-axis? 0, right? Okay, I did want to point out one other thing that we notice as we were generating our y values here, our f of x values. Notice that as x increased by 1, from -2 to -1, from -1 to 0, so it's going up +1, +1, +1, +1. What's happening here? 1/4, if we multiply that by 2, we get 1/2. Multiply that by 2, we get 1. Multiply that by 2. So for our y values, what we're seeing here is that our f of x plus 1, the next y value, right? For the next y value, we get that by taking a times f of x, right? So here's f of x, 1/4. To get the next one, f of x plus 1, we multiplied by 2. Let's see if that works for here, for 3. We'll just get down here at the integers and look at that one. So we are at 1, and we want to get to, and x is 0. F of 0 is 1, right? F of 0 is 1. So f of x 0 plus 1 would be 3 because we multiplied 3 times 1. And then we add again, and we multiply by 3 again and get 9. So we have this relationship, which is often referred to this way: the subsequent y value divided by the previous one will give you your a. And a is our 2 here and our 3 here, our growth factor. We're going to generalize all this now in the next video.